So our second panel is broadly about quantum computing. And this really has come to the forefront now, and there's a group that many of us are involved with or hoping to be involved with the Quantum New Mexico Coalition that we're building. And so we've invited three individuals today. The first being Michael Divitsikiotis. I think I got it right, the pronunciation. I've been working on it.
Yes, you did. You're doing well, bro.
Thanks. Professor and chair of the UNM Electrical Computer Engineering Department. Our second guest is Jacob Douglas, who is Quantum Systems Accelerator Operations Deputy at Sandia National Labs. And then finally, Yorgos Marinakis, who is from the Anderson School of Management, assistant professor, who also works with Los Alamos National Labs, has an appointment there. So appreciate you guys joining us to inform us a little bit about quantum computing. And the proposal that Dave mentioned in the last question, I think we were all somewhat involved with, that had to go to the EDA BBB program, was around quantum computing, and really gave me an opportunity to understand more broadly what that is. So we're hoping for our audience, we can explain that a little bit more as well. So Mike, I'll kick it to you first. Tell us a little bit about how quantum or advanced computing, I mean, I think people use these interchangeably, impacts our daily lives, and maybe give us sort of your one sentence definition of what quantum computing is.
I had to write this down because trying to get a single sentence out of an academic or technical person or a talkative Greek person like me, yes. But anyway, in terms of defining, with the help of a good friend, Ivan Deutsch, who heads a lot of the technical side of this, I condensed it down to quantum computing creates computers and secure communication systems that are based on microscopic laws of quantum physics and aims to solve some of the hardest, biggest problems that we can ever solve, which are basically impossible to solve the conventional or classical computers. Impossible in the sense that it may take you a million years or something like that. So it's be precise. So the emphasis here is that this is a different, this is computing based on these microscopic laws of quantum physics that are coming to the forefront in making these things work. So that's the takeaway. Do you want me to go into the next thing about the impact or the daily lives, or should
please, yeah.
Yeah. You also have advanced computing. I guess depends on how you define that, but the advanced computing is already part of our lives, and it's been there for a while. Some people call that part of the first quantum revolution because the transistor, right? The transistor that is used in everything we have is actually based also on such principles, only that they are not in the forefront, right? And they then dominate like these newer systems. But advanced computing is been around already for a while. It's gaining exponential growth, as we know, with the cloud, with artificial intelligence, in our cars, in the factories, in everything we do around us. Already is being, for better or for worse, being taken over by advanced computing. And it's something that everybody agrees that both for national security purposes and for economic development and all these reasons, we need to stay on top and be strong with, right? So with quantum computing, what happens is that it's been a while known, right, that by Moore's law, so-called Moore's law was this basic law that was predicting this exponential, right, this doubling every so many months of the capacity we have in classical computing. Well, we've been reaching the limits of all of that in terms of the size and the and the frequency, right, how fast the clocks of these things can run for a while now. And already we're reaching the limit there. So quantum computing is seen as one of the options we have going forward for a new paradigm, a new way of doing computing that will then open calculations and simulations and discovery in areas of pharmaceuticals, genetics, advanced manufacturing. Cybersecurity is hugely related. We'll come back to that a little later, specifically because of the cryptographic algorithms and how quantum can affect those. But there is both in terms of computing and then in terms of information sciences and communications, there is huge now attention on quantum, also from a national security point of view, being that you have already on the other side of the world, the Chinese, for example, having established already quantum communication networks that provide foolproof security across long distances. And on the other side, there is this fear or this apprehension that if someone actually operating eventually a quantum computer like it's predicted, they will be able to pretty much break all the cryptographic codes that we have, or the most important one that we are using right now, right? And one more thing I would say about that is that, and we'll have a chance to go back during the panel, it's not just about this one highfalutin exotic thing that one can say, well, fine. There is so much basic research and science and enabling skills and infrastructures that are needed to deliver. I don't want to, we're going to have this in the next question, I know, but to deliver a quantum ecosystem or advanced computing, you need all these skills that would go back to everything that was said in the previous panel, in terms of the workforce, in terms of the skills, in terms of what is needed to be there in the region, right, or in the state, people who can do programming, who can do all these other things, or basic research, all of that is going to have to be there already. So in that sense, this is not like one moonshot that's going to be all or nothing, right, to attain this one goal. It's just a whole bunch of technologies and skills and basic science that would have, and would take time too, going back to the daily lives. Famously, right, again, going back to the transistor, right, was literally invented in 1947, right after the war, but it took decades, right, until we had the first actual computer chip, and more decades until we had anything resembling modern computers. So we are now to where we're doing the so-called the first exascale computer working, and but that is what 75 years since the invention of that transistor. So I'm not saying that we should all, well, yeah, right. We should give it, it's not something that either has to pan out tomorrow or it's never going to happen, right? Like what? So anyway, that's my long answer about that, and I'll give it back to you, Rob.
Thanks. No, I think it makes sense. Like you said, I mean, it's like we're on a path here, right? It's not like an immediate kind of thing. Jake, your thoughts, you know, how does this impact our daily lives? How do you define quantum computing in like a one sentence kind of thing?
Yeah, absolutely. So in my mind, taking a bit of a step back and trying not to duplicate too much, quantum computing is really a next generation computing technology that has the potential to really change the landscape of computing as we know it by utilizing the power of quantum physics. So, you know, quantum computing is still at a very early stage, and I don't think it's impacting our day-to-day lives just yet. However, as it continues to mature, it's going to give us great new tool sets that are going to allow us to solve impossibly hard problems and really disrupt major industries that kind of drive our economy today. Michael just touched on a lot of those and how that impact is going to play out. So, you know, just to add on, you know, it's going to change the way that we secure our systems through cryptography. It's going to revolutionize the way that we can design batteries or drugs, and will really provide new options to discover new materials, providing new solutions for, you know, the space industry or advanced manufacturing. You know, and quantum really has such huge potential that it's seeing huge investments from entities across the world. You know, because the group who's able to develop and kind of commercialize these technologies first, they're going to be able to see huge benefits. So I'll try to keep it short and simple there, and I'll pass it back to you, Rob.
Yeah, absolutely. So Yorgos, from a little bit of a different perspective, what are your thoughts from, you know, sort of you have a hybrid background of understanding these things?
Yes, thank you. Quantum is notoriously complex and difficult, and even scientists argue over how to interpret the basic equations, and there are lots of interpretations now of quantum mechanics. One of the most popular is the many worlds theory by Everett, where when the quantum collapses, it goes off into a different world. It spawns a different world. And and actually there's a PBS documentary where they went and interviewed Everett's son. his daughter actually committed suicide when she was young and said she was going off to a different world. And his son now is a rock and roll musician. So it's just really a very colorful history. And so with that great difficulty, I think it's best to think about the quantum in terms metaphorically. So when I think of the quantum computer, I compare it to a helicopter versus a supersonic jet. So a quantum computer is not a supercomputer, not in the sense that we think of supercomputers now as something being very fast with lots of computations. But what it is, it's very efficient at certain tasks like sorting. So if, for example, if you wanted to drive on every road in the United States, think about how much faster you could do it if every time you came to a fork in the road, you could take both forks simultaneously. Again, this is very simplistic and these are metaphors, but it's just kind of giving you an idea. We're talking about the helicopter versus the supersonic jet. And then given that the quantum computer purportedly is going to be very good at sorting problems, it'll be very good at things like supply chain planning and maybe molecular folding problems. So, but really developing the quantum computer is just such a complex thing. What we really need to develop it is a quantum computer.
Gotcha. It's kind of an iterative process there. I like it. I like it. Well, so now we have that was great. I think you guys all gave incredible pieces to the puzzle there to kind of understand, what we're really talking about here. And not that we necessarily even have to understand the inner workings of it. I think the impact is much more important. So Jake, I'll kick it to you first. How might a hub for quantum impact sort of downstream opportunities? What are your thoughts about what additional infrastructure you really need in a place like New Mexico to support this big industry? And why is New Mexico kind of a logical place to do this? I mean, Sandia is obviously, working a lot in this area, but, what else makes this the best place for something like a hub for this to happen?
Awesome. Yeah, great question. So I'll start off with making sure Michael and Yorgos keep me honest here. But kind of going back to the promise of what quantum can offer, there are quite a few different downstream opportunities across a lot of different verticals. So we've already kind of touched on, the ability to impact the energy sector through material design for batteries, or kind of logistics and networks, or in the high tech fields, machine learning and AI and cybersecurity, or with industrial goods and logistics and manufacturing and material science. So these are all areas that people are currently thinking about. And something that's even more exciting, are going to be the applications that people discover along the way. We have a lot of different tools now, they're new, and we don't quite know what to use them for. So we have lots of room to continue to grow, and the impact downstream, and in my mind, is unknown, but huge opportunity for us. In terms of why New Mexico, we really have world-leading experts and programs and thought leaders that have really helped establish the field. UNM, LANL, Sandia, all have programs that have been around for 20 years. New Mexico State standing programs up. New Mexico Tech has materials work going on. And so, utilizing these really strong and well-established programs, will benefit us hugely. In addition, kind of at Sandia specifically, we have working quantum computers. We have the facilities, the experts, and, we're at the cutting edge. So we should really lean on that and leverage that to build it to continue building in New Mexico. And touching a little bit on the research universities, we have a great opportunity here to help prepare the next generation workforce. We can reach out to communities that traditionally wouldn't be involved in this in a really high-tech area. That's something New Mexico hasn't really seen before, and so kind of in a call back to the previous panel, if we want to make a big bet and do something differentiating, we have that with quantum here in New Mexico.
Yeah, that's great. I think, like you said, we have some resources in place, and really unlike anywhere else in the country, have all these different large institutions lined up. Yorgos, what are your thoughts? What can this downstream effect be for quantum outside of just the great things that the computing can do?
In a word, massive, but it really depends on what you want to do. Do you want to become a manufacturing hub? Do you want to become a use hub? Or test, I think, is really important. Technologists will tell you that test is what leads technology development. So if we were to become a test center, and testing is very important for the quantum computer, if we were to become a test center, we would be attracting people here, because don't forget, now we're competing with Google. How do we compete with Google in their quantum process?
Absolutely. Yeah, I mean, how do we compete with Google? That's a tough one, right? Unless we get them here and on board. So Mike, what are your thoughts?
I'll start backwards since you tossed that there. One of my notes here, I was saying, among other things, like both Jake and Yorgos mentioned, we have tremendous strength in New Mexico already through the labs and through CQUIC and the centers at UNM that have been around for decades. Also on the side of materials, very, very strong across the 3 universities. But speaking of the Google, Intel, that was for a while looked like they were fading or there was uncertainty. Apparently what they're investing in literally here in Rio Rancho is also massively in looking into photonic and items of type of computing that are leading or related to quantum computing already. So here's your part of the answer. And then we have a partnership at UNM with IBM, another one of the titans. Probably them and Google are the closest to demonstrating high-end quantum computing in this country, at least. So we have strategically made partnership with IBM, and we are a member of the quantum network. That's not necessarily the one-and-all solution, but it's put us there on the map and at the table together with other schools and as players. So part of the answer is there to what you're saying. Going back to this business of the downstream, I was talking to preparing for this, right? And I'm thinking this, what I call fun in, right? What goes in the enabling technologies and what we need is infrastructures that would be a great outcome for the state to develop such an ecosystem. And then the fun out, which is what are the results, right? But so I'm going to give you a couple of examples to stay on this notion. What is the impact on the economic development or on the growth or the educational development of workforce in this state? Because I think that's really, at least that's my preferred angle on this topic, right? Just this month, the IEEE Spectrum, the magazine, was talking about nanoscale microscope, right? Very nano microscopes that look into nanoscales that are using AI. And I look at all those complexities. So you have a microscope, which you think a very physical device, especially to be looking very, very small things, well, even smaller things than usual. And then you're using AI to drive the searches through that. And they use that to do quantum material. So now, what's my point about that? Is that look how many pieces go into trying to do something, one thing, or perhaps one solution, one material, one outcome on a quantum device, that you may be in the business of developing the best nanoscale microscopes in the world. Do you see what I'm saying? So that I'm just going to give examples as to what are the infinite potential, not infinite, it's too complicated. Again, going back to the previous panel, as we identify the need and the infrastructure and how we sell the region and the unique being unique, well, perhaps that's what we're going to be looking at, right? Another topic, which is one of my favorite ones. Everybody likes to talk about Shor's algorithm, famously, right, from '94. Famously, that algorithm showed that if you had this hypothetical perfect quantum computer, then we could solve the famous prime factorization problem in days, whereas a normal computer would need 1 billion years, right? So that is the basis on which, I mean, the factorization of prime numbers is what's the basis for our cryptography, right? Basically, the RSA algorithm and what we use for cryptography is based on factoring large numbers. So, okay, that's fine. You can talk about the future of that and how we're going to do it. But listen to this. Coming out of that realization, there is another side industry that's been developed called post-quantum cryptography. Now, post-quantum cryptography, even though it has the name quantum, is nothing to do with quantum. It's is the whole bunch of folks out there trying to find other cryptographic algorithms that would not be defeated or vulnerable to a quantum. Do you see how this now is? So my point here is that you may very well be in this ecosystem where you're developing, and especially in this state with Lanel and Sandia and huge national interest investments on national security and such. You may be actually now the king or the queen of post-quantum and do cryptography. And that's part of, if you want, downstream or the opportunities that are coming out of this. One last thing I'm going to say, classical computing is not going to go away from this, right? Even at its full maturity in like a visionary sense, these systems are going to be hybrid, right? They're going to have a quantum computer, like Jake was saying, quantum computers are better at solving certain kinds of problems. And then classical computers that will be, and there's a whole lot of interfacing and programming and understanding of how that's going to be done. Again, spawning a lot of need there for again, the classical programmers and the cloud people and the all sorts of skills and workforce and capacities that could be very essential to pushing this state forward in terms of the things that we're talking about, workforce, jobs, and so forth. So that's what I'm going to mention, that there's a lot of things that need to happen in the basic sciences and in the applied and the programming. And before you have the quantum computer, after you have the quantum computer, parallel to having the quantum computer. And I think because we're so unique, and Danielle was pointing out that that's really why we're thinking it's a great opportunity with quantum, is the tip of the spear that can show us as unique, but behind it have this whole everything of advanced computing, even manufacturing materials, many of all the topics that are considered the key topics, both in the state development reports and in the national competitiveness reports. So anyway, enough from me. I'm getting excited. I'm sure we'll get a chance to get back to it.
No, that's great. And I think it makes sense, right? It's kind of like it all spawns each other. It's almost like the ball sort of rolling downhill and picking up additional things.
Correct.
Once we get things moving and there's additional infrastructure that's needed, I mean, in all levels of different workforce sort of issues that can be there. And then as the industry develops, there's just the new sort of ways of almost combating it, right? That have to be sort of built up. So that's incredibly interesting. So obviously, quantum computing is huge. There's a lot of different players. And similar to the first panel, when we talked about cooperation versus competition, there is, while we have groups that are all working on the same ideas, it's a little different in the sciences. There still is some level of competition. So Yorgos, what are some of the barriers to moving forward with a large quantum alliance, where you have all these different players who have been sort of working for themselves for a while, now trying to work together? And what are some ways to kind of move past that?
Rob, you just nailed the question beautifully. So I hadn't thought about quantum computing or quantum encryption for the last 10 years. So when I was invited to this panel, I thought about it for a while, then went had a conversation with my colleague, Michael David-Sikiotis. And I don't want to mischaracterize anything we discussed. I'll just say that any good ideas are due to our conversation. Any bad ideas are solely my responsibility. I think what we really need is something like a Manhattan Project for the quantum in New Mexico. But that just raises more questions than it answers. So, exactly what would be the mission of such a thing? Would it include quantum encryption? I think it should. And then, of course, the question is, we have all these entrepreneurial scientists and technologists and programs who have their own funding, their own research programs. We have programs in universities and national laboratories. And it's kind of like pulling people together for the European Union. How do you get these sovereign nations, these independent, successful groups to come together on something new, something entirely new? And of course, you can't expect them to give up their funding and give up their programs. On the other hand, how do you get them to contribute to something where their resources, especially their human resources, may already be stretched? So it's just a very difficult and almost intractable problem. And again, it requires being clear about what the mission is. And then once you're clear about what you want to do, then you can come up with your strategic plan. And then you can come up with your actions based on that strategic plan to make this happen. And then you can start looking for funding opportunities. And the federal government has lots of funding opportunities, and some of them are related to collaborative activities, but a lot of these are still focused on research. And we're not really at the commercialization stage yet. So here again, there's this vagary of talking about putting together this confederacy when we're still just in the technology development phase. Certainly we can add a lot to technology development. We can talk to them about technology readiness levels, manufacturer readiness levels. So again, it's a big problem, but it just requires some planning ahead of time and some discussion and working together.
Makes sense. Makes sense. Michael, your thoughts?
Again, there's this saying this. David asked the question about the 13 EDA BBB proposal. It was part of my, you should have seen me on that day when I was clicking around and emailing frantically about, let me start backwards here. First of all, Yorgo, thank you. I like the European Union example. But you know what? Thankfully, the 3 research universities of New Mexico are not sovereign states. You see, now we can debate that. Well, they're not. Even if they think they are, you can get the presidents and the president here. I'm happy on my behalf, but they are not sovereign nations. Definitely the state, one of my big beefs since I came to this state 5.5 years ago, we have a large, but supposedly self-declared poor state with all sorts of several engineering programs, for example. Again, I don't want to divert, you'll get to my point. I believe that some coordination, at least there, the state or some group, and partly because of putting some targets together, right? Again, to Yorgos's analogy, it doesn't mean that New Mexico State and New Mexico Tech have to give up their identity and who they are and all their lives, but all 3 big schools could agree, should agree, right? We get perhaps the 3 VPRs, whatever. We don't even have that right now, right? We don't coordinate. Yes, there is, but there isn't. Now, going back to the labs, my other topic. Mitzi actually sent me this national competitiveness document, which emphasizes, of course, all of these areas that we're talking about, and mentions very interestingly, right, how important the presence of the national labs is at certain places and how that can be made, can be taken advantage of. Well, then now look at the state's development. What is it? The State Development Office, the report that came out in October, right? What is the #1 conclusion of the SRI, which I think I knew it on the second day I came to New Mexico 6 years ago. It doesn't look that the effect that these huge, amazing infrastructure and resources have sticks. How can I know I'm getting into very, very big, but I like getting into big, difficult topics, right? Somehow, and again, read the state report and read the national report, and this is instead of having a virtuous cycle of innovation and added value, again, there are business people here, Mitzi, Yorgos, all of you, Rob, you are the experts. This is all more like my layperson's terms. Instead of having this virtuous cycle of innovation and development that spawned around with added value around this lab, I'm speaking especially Sandia, and you all can badmouth me as much as you want. What I see here is all sorts of small, everybody, all my colleagues are happily fed, by small projects. But where is the transformative process for this city, for this state? This is, regardless of quantum, one of my concerns around here, or my desires. Coming back to this topic, because you're talking about how it's going to happen. It looks like this idea, Sandia Alliance, finally, Jake, I mean, it's the first time since I came here that there is enough of a directive and a mandate that we shall do this, you see? So this has to be willed, it has to be resourced, and then it has to be coordinated. And I know all of these sound like sort of obvious things after the fact, but I think it's there. 3 great universities, amazing, unique infrastructure with Sandia National and Air Force, by the way. Somehow this has to be, and going back to Yorgos to close that, the European Union thing notwithstanding, thankfully none of the above are sovereign states, even if they want to feel that they are sovereign states, they are not, right? The feds can be put to play with us, and the local universities can coordinate. If nothing else, about one, let's choose one thing, could be this, it could be space. I don't want to ruin this discussion. I can replace this with other things, and you can say that this could be advanced manufacturing, it could be space, or all of the above combined, because this one affects the other, right? But it has to be put in some sense of priority and to coordinate and to, and I think this is, just to stay positive, I am so positive and optimistic that the Sandia Alliance seems to be putting its weight behind the Q&M thing, and then accordingly behind some of these efforts. And then if we have the regional folks, the folks from the previous panel, really finally come together about something like this, then this moves ahead. Anyway, right, you got my big picture here, so please go ahead.
That makes sense. I mean, I think it's similar to what we were talking about collaboration in the first panel too, right? Is there has to be a vision, there has to be, you know, some sort of convener and leader, and we have to identify these things as priorities, and then someone's got to actually make it a priority
Exactly.
from a funding perspective as well. So Jake, I mean, everyone's talking about Sandia. So what are your thoughts on the role of in this sort of alliance?
Yeah, absolutely. So before jumping in too much, definitely don't want to leave out our partners at Los Alamos Labs and AFRL and NMSU. You know, that shared community is super important to this. So I want to throw that out first. So this is an area that I'm really passionate about and care a lot about. And so we have started and formed the Quantum New Mexico Alliance, or QNM, which is made up of the national labs and universities and community colleges and economic development partners. And we're going to continue kind of building these partnerships and programs through a shared vision. But to really capitalize on the opportunities, you know, that was touched on, and realize a payoff for the great and risky decisions and investment to get into the field 20 years ago, we're really going to need to build that shared vision and strategy for the entire state. We need to decide specifically what we want to focus on and push for, and, you know, move forward as a regionally focused group. Is it going to be the supply chain? Is it going to be specific applications? What is that going to look like? We're going to need to really educate people around the state, you know, both from local communities to our best scientists, you know, about what quantum is. We need to build the buy-in to the thoughts and ideas. And answering all of these questions will really help us build the community that's needed, drive the investments, build the right infrastructure, and make sure that we're engaging a diverse group from the community and lifting the state up as a whole. So we need to find ways, and this is a piece I haven't touched on too much yet, but to really establish and support industry. We have great programs at our universities and labs, but we need to bring in that third leg. Everyone knows that industry comes with money and workforce, and so what can we do to help build that? Critical mass workforce is going to be needed in the coming years, so let's start programs now that will, you know, create that incentive. We have really great people and thriving programs, so continuing to build on that, building the ecosystem, you know, that's a really great challenge for us as a state to tackle. You know, and mentioning some of the other sectors that we're really focusing on with aerospace or things like that, we have a really unique opportunity with quantum, since it's so early in the field and it's at that inflection point where it's going to start being commercialized, that if we do take good concrete steps, we can make real change and set New Mexico up as a true leader, in the country. Right now, in my personal view, being pretty embedded within the quantum world, New Mexico is a true leader. And so what can we do to maintain that? And finally, I think another major hurdle that I would really like to see us capitalize on, is equity and inclusion. So we have the opportunity to change computing and sensing and all these types of things, but we also have the opportunity to pull in the communities and workforce that haven't traditionally had access to the field. So working with our community colleges, working with anyone who wants to learn about this new field is something that I think we can be really intentional about and have some great impacts on.
Great. Yeah. Hearing the passion from you guys and the excitement is really great. So quantum can solve everything and change the whole world, which is really true. But to kind of sum things up, and our final question, I'll go to each of you one last time here. So really, how can this transform the New Mexico economy from where we are to where we need to be? And then what do we all as stakeholders need to be pushing our federal, state, and local governments doing to assist this? How do we get these elected officials and these bodies and entities to really take the ball and run it forward? And Michael, I'll give it back to you first.
All right. In terms of transformation of the economy, we have already gotten into this in the previous portions and the previous panel. Let me just be a bit more specific. The key now, based on the downstream items and things we spoke about already, it would be in this case, like in the other technologies too, would be how you disperse and diffuse that through the layers, through the levels, right? So certainly this may sound like this is like a PhD worthy, whatever topic, but it's not just that, right? That's what we keep saying here. All these other required skills and specialties would permeate the bachelor's degrees, master's degrees, I think associate degrees. I think they would have to, this is the type of topic, as we say, that is so go into advanced computing or materials or even manufacturing aspects with modern advanced manufacturing, intelligent manufacturing, all these things. I think that one can model this in a way that can permeate the whole state, both sort of vertically in terms of the levels and geographically, because of it came up actually in the previous discussion with infrastructures and the remote aspect. I think there is remote, right? Modern infrastructure and telecom allows us to project out, if you see what I'm saying, to the corners of the state. In this, we had included something like that in the BBB proposal, like teaching, right, or training or workforce or communicating out, but then also coming in. For example, we have at UNM some proposals in a program trying to virtualize the clean room from CHTM, something that it's only done right now in, I think in San Diego, Southern California. The idea is that you can now give access, as an example, right, to remote folks to be remote controlling or using your clean room or your facilities, for example, in Albuquerque. So I'm just describing there is this technology, especially with telecom and infrastructure, that who was saying it in the previous panel, I was going to say it myself, there is what trillions out there right now, right? Literally for infrastructure, COVID, post-COVID, all of that. Communication is crucial here, right? I mean, networking, internet, right? Broadband, very broadband, very broadband. So project out, project in, then permeate through the layers. I have this vision that, as I was mentioning before, that quantum is not, or computing is not just highfalutin quantum physics, right? Is the machining, if you want, the people who are going to make the lasers or the one device that will be used in the laser that will be used in the optical. Do you see what I'm saying? So there's nothing here stopping us from teaching those skills or training people in CNM or the regional places in Santa Fe, in Navajo Tech and other places, and then having this technical, right, this technician type of trades community out there. And then again, this is not just quantum, it's just that quantum suits us best to be the visible part of it. Underneath that is the whole area of advanced computing and intelligent manufacturing. There is a large EPSCoR proposal now, finalist, that is making it to NSF to be funded hopefully next year, which is all about advanced intelligent manufacturing of that kind with materials. Again, I keep insisting because I don't want you to leave here, especially the lay people, with this notion that, oh yeah, they want to do like cold fusion or hot fusion, or here's another. This is a way to motivate what the state needs to do, which is, right, have a story that allows us to have all this workforce out there. In terms of what they can do, I'll get to my bottom line here. Yes, already the previous panel mentioned, right, there is a grant writing capacity. By the way, I just saw this morning, a state senator is proposing a bill to have the state match some of these EPSCoR projects. It's something that has been discussed. It has to be better coordinated. So the state can match, the state can try to help bring the federal, but also my grand theory, the state needs to take $1 billion from the oil surplus or $500 million and create the New Mexico Innovation Fund, or whatever you want to call it, like this, then break it into either small business kind of opportunities, major ventures. Well, this is all not even my invention, right? This is all written in other models and other books. But in my opinion, unless the state comes and say, I take $1 billion or $500 million and make this endowment for the future of New Mexico, that's going to be the best way to advance. And of course, all the other coordination aspects that we're talking about, matching, grant writing, and so forth. But that is kind of like my grand vision of this. And again, I see both in terms of permeating and then funding. The state has to really decide that they want this, and they can listen. I don't want to. I hate speaking about others, but you know what I'm talking about. Somehow this has to be willed and put into place. And it won't. I'm not a believer in bottom up, right? This notion that all of us will be running a little faster and pedaling a little faster from the bottom, and the whole thing would lift. Right. Anyway, thank you.
Great, great, great. So, Jake, what are your thoughts? What can we do, and how will it transform?
Yeah, so I've been pretty aspirational in a lot of what I said, so I'll provide a little bit to try to back that up. So just to reiterate, quantum computing is still in the early stages of development, but we are at that inflection point where we can set the state up for success by making really smart and strategic decisions and investments now. So, according to BCC research, the commercial market for quantum computing was 33 million in 2017, which is pretty small. But it's expected to grow to over $1 billion in the next few years, and it's going to grow rapidly beyond that. We've seen pure play quantum companies go public through SPACs and INQ, and there's announcements that even more are coming in the near future. We're really seeing that unprecedented investments from government and risk capital and companies to develop these quantum technologies. As a state, I think we really need to leverage the unique assets and expertise and capabilities that we've spent the last 20 years developing to take advantage of this growth and these opportunities. And, again, to set New Mexico up as a national leader in the field. We need to create the economic development programs and incentives. We need to modernize labs. We need to invest in the infrastructure and, the critical piece of workforce. We need to build the critical mass that's going to be ready in the 4, 5, 6 year time horizon when this is really going to be exploding. So to zoom in a bit more on New Mexico, how are we going to transform the local economy? Quantum has the opportunity to really enable advancements on a number of the current New Mexico investment priorities, so cybersecurity and intelligent manufacturing, biosciences and health. So not only is quantum going to move forward, it's going to enable a lot of other fields. We've touched on a lot of the supply chain pieces. If we train people how to use lasers, that's going to be useful in quantum adjacent fields, not just for us. Same with cryogenics or things of that nature. So how can we build the facilities to train students? Can we leverage our community colleges and create these novel types of programs that people in the country are really looking for because we have the ability to create and support these programs. So, getting that coordination and building that community with our community leaders and with our, national labs and universities and everyone else is really going to help establish what we need to do something meaningful in the state.
That's great. That's great. Yorgos, as our resident policy expert on this sort of stuff, what are your thoughts?
I would say that a nation will not be a sustainable 21st century power without the quantum. And I acknowledge there's a lot of hype, a lot of exaggeration around the quantum. I don't think that's around the promise of the quantum. I think that may be around the timeline. So it may be that we don't get the 100 qubit fault tolerant quantum this year or even next year or even 5 years from now, but we're going to get it. And it's going to deliver everything we've been saying. And in addition to the specific examples my fellow panelists have given, I think we need to also be aware of the iceberg analogy, where what we see may be only a small percentage of what is coming. And so what I would tell policymakers and representatives is the story of Nick Metropolis, who was the Greek on the Manhattan Project, and he would come to our house for Greek food. And I remember the last time he was here, and I remember the last time I saw him. And he was he brought the supercomputer to Los Alamos in the 50s. He went away after the Manhattan Project to University of Chicago, then came back in the 50s and created the first supercomputer. And one of the largest buildings at Los Alamos National Laboratory is the Nick Metropolis Supercomputing Center. And by the time I thought of this question, it was too late. He was already suffering from advanced dementia. But I really wanted to ask him, did you ever really have an idea of how important the supercomputer would be to the laboratory and to national security? Because once we signed the test ban treaty in, what was it, the 95, I think it was the 90s, all nuclear weapons design and testing is now done by supercomputers. We're not allowed to test nuclear weapons anymore, so how do we test them? We simulate them with supercomputers. And all those nuclear weapons sitting in silos and submarines and ships, they're not inert, they're decaying. And it's the supercomputer that's simulating that decay process and what we need to do to maintain them. I don't think Nick Metropolis knew that this specific use of the supercomputer would be in its future, or that it would even be the center of our national security infrastructure. But that's what happened, and that's likely to happen with an advanced emerging technology like the quantum.
No, I think that all sort of makes sense. And moreover, we needed to introduce another Greek name into our discussion today.
Oh, but you're talking about the right one. We're talking about the gods of I didn't know, Yorgos, that you have talking about someone who has names on algorithms, on books, on everything. I kind of grew up. If I can say, again, the Manhattan Project, the whole military effort, the Cold War, it's all full of examples of technologies that were unintended or unpredictable even, or we cannot even know. The GPS, I mean, everything around us in a way came out of unexpectedly very often, right? Like Yorgos says, out of people trying to do this, and then 10 other things came out that are now essential to our economy. So, right, anyway, you all know what I'm talking about.
Absolutely, yeah. And there's some questions in the Q&A too about the word quantum. Is it kind of like the word space? Is it just something that excites people? It's really a massive area, which I think we've definitely sort of tried to tackle. There's just so much that's here. So with that, I've always learned that you never want to be the guy holding people up from going to lunch. So I think we'll stop here, and I'll thank you all for your time, your tremendous contributions to the discussion. I think there's really a lot more we could discuss, right? Because we don't even know where this is going to go. Just a great combination of thoughts and inputs on this topic, and really combined with the first group talking about some of the economic development directions we can really move in the state, I think really exciting for all of us. So thank you all for joining us. Thank you all for taking the time and preparing and giving us some great insight here. Thank everyone for joining us today. I really also want to thank our team, Megan Borders, you may have seen there, who did all the event planning for us, and then Anna Dykman and her marketing team as well, who really did a great job in terms of putting everything together and making sure everyone is on the same page. We will get this posted as well, and so folks can go back and watch it and share with other individuals. And with that, I will say thank you all so much. Please stay safe. Have a great holiday weekend, and thank you for your time.